Hi, in this video we're going to talk about parallel and perpendicular lines. In two-dimensional coordinate plane, two lines are either parallel or not, meaning they intersect. Parallel means if two lines are parallel they don't intersect, and if they're not parallel then they intersect, right? Now, while parallel is interesting, intersection is not very interesting unless the lines are perpendicular, meaning the angle between them are 90 degrees. Now, right, so these two lines are seemingly parallel, but how can I prove or show that they're parallel? Now, let's calculate their gradients. Calling this one as L1 and this one as L2, as line 1 and line 2, the gradient for the first line, L1, would be the comparison in change in y. Well, this is 4 squares here, and the change in x, and this is 2 here. So if I write the gradient of L1, that's going to be 4 over 2, which is 2. Let's do the same for L2. Now it's going to be, let's start from here, right? And if I go like this way, I can see that again the change in y is 4, whereas the change in x is 2. So I can go on with the same calculation, ending up with the same gradient. Now, the rule is, if L1 is parallel to L2, then their gradients are the same, meaning the gradient of L1 is equal to the gradient of L2. Now, notice that I put an arrow in between showing two directions. This means you can read this sentence either from left to right or right to left. Both is valid, both is true. So meaning I can say if L1 is parallel to L2, then the gradients are equal. Or I can say if the gradients are equal, then the lines are parallel. So it works both ways, and this is how I show it. So let's look at this example now. It says show that the line with equation y equals 4x minus 1 and the line with equation 2y minus 8x plus 18 equals 0 are parallel. Well, I have to show that their gradients are the same. So for the first equation, the gradient will be 4. So m equals 4. Let's say m1. And then the second equation, 2y minus 8x plus 18 equals 0. This means 2y equals 8x minus 18 if I take these to the other side. And if I divide both sides by 2, I'll have y equals 4x minus 9, which implies the gradient of this equation is also 4. So just because the gradients are equal, right, the lines are parallel. That's how we use this rule. When it comes to perpendicular lines, right, meaning when two lines intersect with the angle of 90 degrees, then their gradients multiply out to -1. So for L1 and L2, if the gradient of L1 multiplied by the gradient of L2 is -1, then, and this is also a two-way arrow, right, then we can say L1 is perpendicular to L2. So if L1 is perpendicular to L2, then their gradients multiply out to -1. So it works both ways as in the parallel rule. So let's calculate those gradients now to see if this is the case. For L1, the change in y is 3, whereas the change in x is 1. So the gradient of L1 will be the comparison of these changes. So it's going to be 3 over 1, which is 3. Whereas for the gradient of L2, the change in y is negative 1, whereas the change in x is 3. So that's going to be minus 1 over 3, which is, well, minus 1 over 3, right? So if I multiply these, minus 1 over 3 times 3, I end up with minus 1. So yes, the rule works. Or, in other words, L1 and L2 are perpendicular. Now, if you're confused with the rate of change here, the change in y being negative here, then let's write the coordinates of those points that we chose, right? And then calculate the gradient of L2 with the coordinates of these points. So if I take the coordinates of A and B as 6 to 5 and 9 to 4 and do my calculation, well, it's going to be 5 minus 4 over 6 minus 9. So I'm going to end up with 1 over negative 3, which is negative 1 over 3. Or if I was to use the other way around, like B and A, so it's going to be, alternatively, 4 minus 5 over, right, 4 minus 5 over 9 minus 6. Again, ending up with minus 1 over 3. So if you're not sure about the sign of those changes, change in x and change in y, then you can just pick some points on the line and then do the calculation. Well, let's look at this example. Here the first equation is 5y minus 3x plus 4 equals 0, where I'm going to write down 5y equals 3x plus 4, and dividing by 5, I'll have y equals 3 over 5 x plus 4 over 5, and the gradient here will be nothing but 3 over 5, whereas 10x plus 6y minus 11 is 0, meaning here 6y equals minus 10x plus 11, and y will be minus 10 over 6 x plus 11 over 6. So if I write the second gradient here, it is minus 10 over 6, which simplifies to minus 5 over, not 4, 3. Now if I multiply these two gradients, 3 over 5 and minus 5 over 3, then I can see that 3's cancel each other out, 5's cancel each other out, I only have negative 1 remaining. This implies that the lines are perpendicular. The lines are perpendicular. Now in this example, we are asked to find the equation of the line that passes through the point P and parallel to the given line equation, the given line, right? Now, we need to write down the gradient and the y-intercept of the line so that we can find the equation of it. So for the gradient, we're going to use the parallel rule. It is given in here. Basically, for y equals minus 3x plus 7, the gradient is minus 3, so I can start writing the equation of the line that I'm asked to find as y equals minus 3x plus c. At that point, I'm going to substitute the coordinates of P into this equation. So it's going to be 4 equals minus 3 times minus 1 plus c. This is 4 equals 3 plus c, so c is 1. And now I can write my equation, y equals minus 3x plus 1. So this is the line equation that I'm asked to find. So what if we are given a perpendicular line to get the gradient from? Well, here's this example. Now I'm going to play with this equation to get the gradient out. So basically it is 5y minus 7x plus 19 equals 0. I have 5y equals 7x minus 19 by taking these two terms to the other side. And if I divide both sides by 5, I'll get y to be minus 7 over 5x minus, sorry, it's not minus, it's plus 7 over 5x minus 19 over 5. From here I can write the gradient to be 7 over 5, right? So if these two lines, the line I'm asked to find its equation and the line which is perpendicular to that, if these two are given perpendicular, I'm going to go like 7 over 5 times m2. This is the gradient of the line that I'm supposed to find the equation of, right? These two must multiply out to minus 1. Here, you can say times 5 to both sides, cancelling these, and ending up with 7m2 equals negative 5, and then dividing by 7, you can end up with m2 being minus 5 over 7. Or you can divide both sides by 7 over 5. Or you can just memorize the fact that if you have a fraction, you have to flip it and change the sign to get the gradient, right? In either way, the gradient of the line that I'm trying to find the equation of is minus 5 over 7. Now, I'll write the equation as y equals minus 5 over 7x plus c, and substituting the coordinates of the point that the line passes through, I'm going to be able to find c. So it's minus 3 equals minus 5 over 7 times 4 plus c. From here I'll get minus 3 equals minus 20 over 7 plus c. And then here I can write that c is nothing but minus 1 over 3, right? So I do this by taking this fraction to the other side and so on. Right, so it's going to be y equals minus 5 over 7x minus 1/3. So this is the equation I'm looking for. Now the question might ask me to write it in the form ax plus by plus c equals 0, which I'm going to play with this a little bit and find out that it's going to be 21y plus 15x plus 7 equals 0. Right, now 2 questions for you to solve on your books and submit your answers online. Thanks for watching.